Fundamentals of Magento Development, Unit 4. Fundamentals of Magento Development, Unit 4. In this module, we will talk about declarative schema. This is a framework for creating and implementing database tables that was introduced in Magento 2.3. Before 2.3, in Magento, we used install schema, upgrade schema, install data, and upgrade data scripts for this purpose. Since 2.3, we should use etc db_schema.xml for creating and manipulating tables and data schema patches for other operations, such as create an attribute, and so on. Declarative schema in Magento 2 consists of 4 elements. etc db_schema.xml file. This file is used to create new tables and modify existing ones. etc db_schema_whitelist.json. This file enables other modules to modify database schema created by the module's etc db_schema.xml file. Data patch files allow certain operations with data to be executed at module installation time. An example could be add a new product attribute, setting some initial data on the tables. Schema patch files let you modify database schema with direct SQL operations. Normally, we modify schema with etc db_schema.xml, but it has limited functionality, and such things as triggers or stored procedures are not supported. Please note, every time you make any change with these files, you should run the console command bin magento setup upgrade in order to activate the changes. On the slide, we can see a syntax of a db_schema.xml file. First of all, we should specify table node. Please note, db_schema.xml files will be merged in the same way as any other XML files. So if we want to modify an existing table, we also start with the table node. Table node has 4 allowed attributes: name, resource, engine and comment, all self-explanatory. Inside of a table node, we may have 5 different elements. Column will be covered on the next slide. Primary key, implemented with the constraint node with XSI type equaling primary and reference ID equaling primary, as shown on the slide. Foreign key, implemented also with the constraint node with XSI type equals foreign, reference ID equals to the key name, and table, column, reference table, and reference column attributes, which defines the foreign key. OnDelete attribute defines onDelete SQL action. Unique key, implemented with constraint node with XSI type equal to unique, is shown on the slide. Regular index implemented by index node. On this slide, we can see attributes for the column node of the db_schema.xml file. Please note disabled attribute. Because different schema files are merged into one, it is not possible to remove a column from the final configuration file. For this purpose, we may add the same column again, but with the attribute disabled equal to 1, which will disable the column in the final schema XML file and remove the column from the database when bin magento setup upgrade command is executed. By default, Magento does not allow other modules to modify db_schema.xml that was created in a certain module. However, the module can allow this operation by specifying the etc db_schema_whitelist.json file, where db_schema.xml elements allowed to be modified in other modules are listed in JSON format. You don't have to create the db_schema_whitelist.json file manually. This could be done with the console command shown on the slide.
In this video, we will show an example of how to use Magento declarative schema. For doing that, we will create a simple module, which will add a table called badge, training badge, with 3 fields: name, code, and price. Let's create a module first. We will do it in the app code folder. If you don't have a code folder, go ahead and create one. So we will create a subfolder, Magento U, for our namespace, and a new subfolder, training, for our module. And to make module functional, we would need etc subfolder. We would need train registration.php file, and we would need etc module XML file. And we would also need etc declarative schema, db schema.xml. So those are files we need, and now we should fill them with some data. We will reference Magento core module, Magento catalog, just as example. So first we create registration PHP, Magento U training. Next, we will create a module XML. And again, we will take a look into the catalog module. We will copy declaration from the catalog module and paste into our one. We call it Magento U training. And we will leave reference to catalog module. We don't need it for this exercise, but just as an example. So we have registration PHP, we have module XML, and now we need db schema.xml. Again, we go to the catalog module, and there is a db schema XML file there. So we will copy table declaration. So the way how we create tables in Magento is creating db schema XML files and describe it there. So now we have to edit this file. So we will call our table training badge. We will change the comment to training badge table. We will have badge ID. And we will leave another varchar field name. And we will leave everything else so far. I will remove everything else so far. And so this is badge ID. And so this is how we create a table. So we create db schema.xml file. And in this file, we use this declarative approach. We declare a table node and create columns using column declaration. We can use constraint declaration to create primary key, unique key, or foreign key. And we can use index declaration to create indexes. Now, how do we make our table active? For doing so, we will open a terminal and we will run command php bin magento setup upgrade. We have to wait a little bit. Our module become active. So we still wait. And that's it. we can take a look into the app etc folder. There is a file config.php. We can search for Magento U. Here's our module was added. And finally, we can take a look into the database. And see if we have our module here, we have our table ready. So this is how we add a new table in Magento declarative schema. In this video, we will show how to modify existing table. So we have created a training page table before in the previous video, and in this video we will add a few more columns to it. In order to add a new column to an existing table, all we have to do is to add new table declaration in the dbschema.xml file. Please note, if we are about to make a change that may cause any damage, like data loss, for example, remove the column or change column declaration, we would have to make sure that this column that we go about to change is listed in the dbschema whitelist JSON file. So let us take a look into the catalog module again. It has dbschema whitelist JSON file, which has a list of all the fields which could be altered in the way that may cause data loss. So we have to generate the same file for ourselves. There is a console command which can do that. However, what we're going to do here is to add a new column, and adding a new column is an operation which does not cause any damage. So we don't need this file yet. For doing that, we will reference back to our catalog module. We need to add two new columns, code and price. And for code, we actually can use an existing declaration of the column that we had before. We had varchar column, so we need varchar column again. It would be code. And we need to fix the comment. So in this case, it would be code page code, and here's comment is page name. Now we want to set the decimal column, and again we can look decimal column in the catalog module. In the catalog module, in its dbschema XML, we can find anything that is possible to do in the dbschema XML. So it's a new column, type decimal, name would be price, scale precision 4, comment would be page price. Next, we may want to add an index, a unique index, and just regular index. So for adding a regular index, there is an index node we can use. We will give index a name, training code. So we will make, let's make it price, training price, and it will be price field. We may add more fields if you want. And we can also have a unique index, which is done with a constraint keyword. So we have constraint, type unique, we will call it training code. And we only have one column code here. We can add also a foreign key in the same way. You can see an example in the catalog module how a foreign key could be added. So far, we don't need any foreign keys in our training page table. Let's now go to the terminal and execute the same command, php bin magento setup upgrade. Now we wait a little bit for our code to be executed. And when it's done, we will check database to see that our new columns were added. this is how you work with columns in the database in Magento using declarative schema. So we want to say training page, and we see our new column have been added. We see code and price. We can also do show create table training page, and we can see we have our unique key, we have our primary key, and we have our regular key price. So, summarizing it, in Magento 2, using declarative schema approach, in order to create or modify an existing table, you should use dbschema.xml file. In case you want to do a change that may cause a damage, theoretically, you need to ensure that columns you are about to change and indexes are listed in the dbschema whitelist JSON file. That file can be generated automatically using command line tool. If you need some very complex changes to the schema, like adding triggers or stored procedures, you have to use dbschema patches PHP files rather than dbschema XML. Usually we don't need such difficult changes in our table structure, so we are using dbschema XML. You can use dbschema XML to change a table that was introduced in another module. For example, in our Magento U training module, we could add another declaration like table and use schedule of product entity, for example, and add a new column here or modify existing column from a table introduced by another module in the same exact way. Schema XML files would be merged together. Magento will find a delta, will figure out which columns need to be changed, and will execute appropriate schema change SQL command.
On the slide, we can see an example of a data patch file from the Magento_store module. Data patch has to be located in the Setup Patch Data folder of a module. It should implement Magento Framework Setup Patch Data Patch Interface. It may implement Magento Framework Setup Patch Version Interface, which adds getVersion method, which is used for conversion from the old 2.0 through 2.2 setup scripts. For newly created data patches, Magento does not use versions. Instead, it uses dependencies and aliases, which we will cover in the next slide. Another important element of the data patch file is an instance of Magento Framework Setup Module Data Setup Interface, Module Data Setup in this case. It provides access to the key objects required for SQL manipulations. For example, Module Data Setup getConnection provides a connection object that allows the execution of SQL. Module Data Setup getTable provides a name of a table by the alias. For example, if the Magento instance has a table suffix sf, then the module data setup getTable store group returns sf_store_group. On the slide, we can see a code snippet from the Magento catalog setup data patch update product attributes class. We can see an implementation of getDependencies method, which returns an array of class names which it depends from. This example means that update media attributes backend types data patch file has to be executed first. Alias is used to provide a shorter name for a data patch, to be used in the other data patch's getDependencies methods. Typically, getAliases returns an empty array, and dependencies list real class names. Schema patch files are very similar to data patch files. They have to extend Magento Framework Setup Patch Schema Patch Interface and obtain Magento Framework Setup Patch Schema Setup Interface instance in their constructor. Schema Setup object provides access to the connection object and other objects related to database operations, which will start or commit a transaction.
In this video, we will show how to create a data patch to populate data for the table that we just created. For the table training page, first of all, we go and create new folder called setup. Now when we have setup folder, under the setup folder we create patch folder. Patch and patch data. And we will create our data patch file. There is no requirements for the name. In our case, we will have it install page.php file. Okay. So now we create the file. We will use under the namespace Magento U training setup patch data. We would need to use Magento framework setup patch data patch interface, and we create our class install page implements data patch interface. Okay, now we need to create a constructor, public function construct, and in the constructor we would need an instance of another class, the Magento framework setup module data setup interface. Module data setup allows us to get access to the database connection, which we need to populate the data. Module data setup. Okay. And we will assign it to protected variable. This module data setup equals the module data setup. We create protected variable here. Setup. This would be variable Magento interface, like this. And here we add another doc block, param module data setup. Okay, so now we can implement our setup itself. We do it by implementing apply method. In the apply method, we will create a data for our data that we want to enter. We have three properties of our page. Its name, let's call it test page. Its code, let's call it test page, and price. Let's make it 12.22. Do it as a number. And let's make a couple of records like that. So let's say second page, let's make third page, make simple page, simple page. Okay, now we have to insert this data. In order to insert this data, we use this module data setup, get connection, start setup method, start setup. This will initiate a transaction, and now this module data setup get connection. This is how we get access to the connection object, which allows us to insert data in the database. And we use insert multiple method. First, we have to specify the table. It is important that we use a method to get table name, because Magento may be installed with prefix, and so we want to make sure that we get the right table name, and then data. That's it. And finally, we have to commit transaction, and we do it with end setup. There are a few methods more that we have to implement here. First, we have to implement method public static function get dependencies. in this method we have to specify from which data class is our class dependent. This is how in Magento 2 we specify dependencies between classes. Before we were using versions in Magento 1 and Magento 2.0 until 2.2. Now we have dependencies, and we have aliases, get aliases, which we also don't have any. Okay. Now we are ready, so we can go open terminal and run command php bin magento setup upgrade. Now we wait a little bit. And now we check whether we have our data setup executed or not. And we see that our data is in the database. So our data setup was executed. We may see, let's take a look into that. We can see where does Magento store information about data setup. It's also in the database, in the table patch list. Let's look at this table. It has only one field, patch name. We can say select everything from patch list, where patch name like Magento U. And we see that our install data setup script is here, which means second time when we run command bin Magento setup upgrade, our setup file will not be executed again. So this is how Magento tracks it. So let's look once again, how do we create a data setup file? We create a file in the namespace setup data patch data. We create a class that implements data patch interface. In the constructor, in addition to classes that we need, in our case we don't need any, we put a module data setup instance, and then we can use this module data setup to start transaction, to insert records into database, or perform any database manipulations we need, and to commit the transaction. And this is how data patches works in Magento. If our data patch dependent on another data patch, we will specify it in the getDependencies method. We can use getAliases to provide simpler alias for data patch to use in some other data patch class getDependencies method.
On this slide, we can see two commands that could be useful for migration or upgrade from Magento 2.0, 2.1, 2.2 to 2.3. Those commands will generate db_schema.xml files based on existing install schema and upgrade schema files. Note that you will have to convert install data, upgrade data files manually.
See your course exercise guide for instructions on how to complete this exercise and its solution. In this module, we present an overview of how databases work within Magento 2. The Magento ORM is used by the repository implementations that are part of the Magento 2 service contracts. The service contracts will be covered in more detail in Unit 5 of this training. In this module, we will discuss module setup, representation of entities, and responsible access to data storage. Object Relational Mapping, in short ORM, is a technique used to persist objects from an object-oriented language such as PHP in a relational database. The Magento ORM is built around models, and resource collections. The Magento ORM elements are models, resource models, collections, and resources. Models are data and behavior representing entities. Resource models are data mappers for the storage structure. Collections encapsulate sets of models and related functionality, such as filtering, sorting, and paging. Resources are data connections via adapters. The ORM gives you the capability to create, load, update, and delete data to the database. A collection in Magento is a class that implements the iterator aggregate and the countable PHP5 SPL interfaces. Collections are widely used in Magento to store a set of objects of a specific type. The Magento ORM concept requires that only models contain and manipulate data. Magento has a very flexible, highly abstract concept of what a model is. Anything that is represented by a database table is most likely going to be a model. Note, the CRUD acronym stands for Create, Read, Update, and Delete. Models encapsulate storage-independent business logic. The models generally do not know about data persistence. Resource models encapsulate the storage-related logic. All storage layer-related actions are the responsibility of the resource model. The resource model uses the database adapter to access the storage. It populates the model with the data from the database in case of a load operation, or writes the model data to the database in case of a save operation. The benefits this approach offers are decoupling of the business logic and the storage layer, and decoupling of the storage schema from the DB driver implementation. This design pattern is known as data mapper. Resource collections represent a list of models of a specific type. This approach is used for working with multiple records. The model contains the deprecated CRUD methods load, save, and delete that delegate to the resource model. Developers striving to write upgrade-safe code should not use the CRUD methods on the model, as they will be removed at some point in the future. Instead, the model should be passed directly to the CRUD methods on the resource model. The model has no direct access to the database, only the resource models. So if you need some special data from the database, you have to create the appropriate method on the resource model. The resource models access the database through Magento Framework DB Adapter PDO and then DB. When creating a new model that interfaces with the database, the model needs to know which resource model to use. This is why the class name of the resource model is specified using the _init method in the protected function _construct. This is required to support the inherited abstract model methods getResource and getCollection. To create the model, you just create a class and extend it from Magento Framework Model Abstract Model. With Magento 2, you no longer have to declare the model, resource model, adapters, and more in the configuration. You just create the model class and extend it from the Magento Framework Abstract Model. Note that you call the _init method from a single _construct method, not the real double underscore PHP constructor. A resource model extends Magento Framework Model Resource Model DB Abstract DB. Again, note the single _construct method. Do not confuse it with the real PHP constructor. You need to define the table name and the primary key field name for the resource model because it needs to know where to save the model state. They are specified by calling the _init method in the protected _construct method.
The collection extends Magento Framework Model Resource Model DB Collection Abstract Collection. When creating a resource collection, you need to specify which model it corresponds to, so that it can instantiate the appropriate classes after loading a list of records. It also needs to know the matching resource model to be able to access the database. This is why the class names of the model and resource model are specified using the _init method in the protected _construct method. The remaining code you see on this slide is optional.
The base class for Magento models is to extend Magento Framework Model Abstract Model. In Magento 2, each model that uses the storage layer has one corresponding resource model and one corresponding resource collection. It might appear that models take an active record approach because they expose save, load, and delete methods. But in fact, they delegate persistence to the resource models as data mappers. These CRUD methods that the models inherited from the abstract model are marked as deprecated and should no longer be used. Models that are not storage persisted are somewhat of a legacy from Magento 1 and the fact that you had to place many classes under the model directory. In Magento 2, you can place classes under any folder. True models are those that represent entities and which extend abstract model. The API will be covered in more detail later in the course. For now, it is important just to note that you can create an API layer in order to make it easier for developers to work with the application without knowing about the workings behind it. Magento 2 models inherit automatically fired events, which use the event prefix and event object properties to customize the event name to the specific model type being operated on. Again, we will discuss APIs in more detail in the next unit. The purpose of this slide is to point out that the API you program against for resource models is implemented by Magento Framework Model Resource Model DB Abstract DB that every resource model inherits from. We can consider resource models to be a service layer between models and the database storage. They help us to work with the database, that is, to get, save, and update data. Basically, any model can be connected to a specific resource model that implements access to the database storage layer.
This diagram reminds you how a resource model and database adapter are connected. All read-write connection getter methods retrieve the resource connection instance by resource name with a fallback to the default connection. GetConnection method gives an access to the MySQL adapter. The Resource Connection module from the Enterprise Edition provides features to share databases, achieving higher scalability.
The API you program against for collections is implemented by Magento Framework Model, Resource Model DB, Collection, Abstract Collection. Collections provide several useful functions for defining and working with a result set. This diagram shows how a collection is loaded. A resource collection is needed to create a set of model instances and operate on them. Resource collections lazy load the record set they represent. The first time the item list is accessed, a collection will load automatically. After that, a collection will not load again, even if the load method is explicitly called. Collections are very close to the database layer. Their task is to retrieve a set of rows from the database, then iterate over them, and for each row, instantiate the matching model class. It solves these main problems. Provide a container for storing collections of objects. Prevents unnecessary loading of data. Stores all objects during a session. And it provides an interface for filtering and sorting entities of a specific kind. This is a good reference slide to remind you how collection filter operators can be specified and how they map to SQL where conditions. See a course exercise guide for instructions on how to complete this exercise and its solution. We will now examine models and their related workflow in more detail. In this module we will discuss the CRUD workflow, which consists of model reading, saving, and deleting. When passed the model and the second parameter, the resource model load method will return a record whose ID field, which is set in the model's resource, matches the second method argument. The optional third parameter may be used to specify a field that is matched against the second argument instead of the ID field. However, categories and products, which are EAV-based entities and will be covered in more detail later, can be loaded using load by attribute instead of the third argument to the resource model load method. The deprecated model load method internally calls the method _before_load, which triggers the two events model load before and event prefix load before. Since the model load method will be removed at some point in the future, it is better to use plugins into the resource model load method instead of relying on these events. This code is from a resource model. The method getLoadSelect is used to build an SQL query to retrieve the relevant data. The afterLoad method is used for processing an object directly after loading the data. Every time a Magento model is loaded, you can intercept it by observing the events modelLoadBefore and modelLoadAfter, which carry a simple data transfer object. Under the key Object is the model instance itself. As you can see on the slide, there also is a more specific event, which uses an entity-specific prefix. In Magento, most of the core models redefine the internal variable event prefix, so one can observe CRUD operations for specific models. To determine the prefix used for a model, you need to check the model source code. Be aware that events like modelLoadBefore and modelLoadAfter will not be dispatched while loading a collection. This is because a collection does not load each item individually, but instead loads all models in the collection at once. Core collection abstract load before and core collection abstract load after will be dispatched once for the complete collection, along with specific events like load before and load after, with the matching event prefix prepended. Since models inherit from Magento Framework Model Abstract Model, you can easily get the originally loaded data without any modifications that might have been made using the public method getStoredData. Another helpful method models expose with public visibility is hasDataChanges. By using this method, you can check if the model data was changed since the last time the model was loaded or saved. The save method on the resource model has to be called with the model as an argument. Note that the save method on the model has been deprecated. Actually, the method does both. If the isDeleted parameter is specified, it sets the isDeleted flag value. Otherwise, it returns the current value. This slide is self-explanatory. The method validateBeforeSave uses a validator, which contains all the rules to validate the current model. It is called by the resource model save method. The model's beforeSave method is called by the resource model save method. In the resource model save method, the dataSaveAllowed flag can stop saving after the beforeSave method was called. This can be helpful in case some data validation failed. The resource model starts the transaction, dispatches before and after delete methods, cleans the model cache, directly deletes the data from the database, and then commits the transaction if there were no errors. The events are also used to check if the delete action is allowed for the current area and to clear the model object-related cache. The delete after events are used for processing the object after its data has been deleted. It also dispatches the clean cache by tags event. This slide is self-explanatory.
In this video, we will show how to create model, resource model, and collection for the new tables that we have created before in our training module. So first of all, in our module, we will create a subfolder model. In the model subfolder, we will create a new folder called resource model. In the resource model subfolder, we will create a new subfolder called page. And we will create a few files. We will create model page PHP file. We will create a resource model page PHP file. And we will create a resource model page collection.php file. So we have folder model, and we have model page PHP. We have folder model resource model, and we have file model resource model page PHP. And we have folder model resource model page, and we have collection.php. 3 files. Now we have to fill those files with content, and we will, as usual, reference to our core code. And we will not use Magento catalog module this time, because catalog module is EIV module, and we want a flat model, resource model, and collection. We will reference to module cron, for example, and we will take a look at the schedule model, schedule resource model, and schedule collection. So let's start with the schedule model. What we will need to do, we will need to have this construct function and just a general declaration of a model. So we copy that and we put it here. Yep. So let's see, we have to change namespace to Magento U training model. We don't need those lines of code, we don't need comments, even so it's a good practice to have comments. Have to change it to page. And now what we have to do is we have to add that single underscore construct function. So we will copy it, paste, and we would need to init it with our resource model, which would be Magento U training resource model page class. That's it. This is enough to have a functional model. Now, next step would be to create a resource model. For resource model, we would follow the same structure. We would need to have a underscore construct function with one underscore, and we would have to say what table and what ID field of the table Magento has to use. So we will go to page resource model, paste it again, change namespace, Magento U, training, model resource model, remove comments, change schedule to a page. We will extend the same file, Magento framework model resource model db abstract model, and we will have to say that the table is training page, and ID file, ID field is page ID. This is enough to have a functional resource model. Now let's take a look at a collection. Collection follows the same pattern. So we need underscore construct method, and we have to init collection with our model and resource model. So this is what we're going to do now in our collection class. So we change namespace to Magento U, training, model resource model beige. We will strip those comments. We will extend the same method abstract collection, the same class abstract collection, and the only thing that we have to change is Magento U training model beige class, Magento U training model resource model beige class. Okay, here we go. So we have our model, resource model, and collection. We are all set here, and we can test whether they work or not. In order to test them, we will create a new controller. Let's make a new folder frontend. And we will add a new routes.xml file. We want to make a controller that we can hit. And for doing that, we will look into the catalog module, or we can look, let's look into catalog. Module. So we need ATC frontend routes.xml file. So we will copy it and paste to our module. So we will paste it here. And we will change routes.xml. So route ID would be training, front name would be training, module name would be Magento U training. And we will create a controller folder. And in that controller folder, we will create subfolder beige. And in that folder, we will create a file index.php. Now we can create this file. In this video, we will test our model, resource model, and collection that we just created. For doing so, we would need to create a controller. So in the etc folder, we will create a frontend folder, and we will copy routes.xml file. So we will again refer catalog module. We will copy routes.xml file from here. And we will insert it here. Now we will modify it. So it will be training, front name training, it's Magento U, and module training. Okay, this is done. Now we create a controller. So we create a controller folder. Controller. In the controller folder, we create beige folder. In the page folder we create index.php. Now create this file. So we in the namespace Magento U training controller page. We will use Magento framework app action, and also we would use action context file, and also we would use our new file that we created. It's Magento U training model. We will use page factory, and we will also use we will not use them in the controller. We will use them in the view model. So let's create a controller file. It's class index extends action. Now let's create let's also use Magento framework view result page factory. Let's double check to have this method. It's Magento framework app Magento framework view result. Yes, we have page factory here. We have public function construct. We'll use context and page factory. Okay. We will call parent construct context. We will use this page factory. We will have a protected variable page factory, which is our Magento page factory. We would have parameter context, and we would have another parameter page factory. Now we will do execute function. This page factory create, and we just return page. So we will have very simple controller. Now we want to create a layout XML file and view model. So first we create layout XML file. We will create a view folder. In the view folder we will create frontend folder. In the frontend folder we will create layout folder, and we will create templates folder. Okay, in the layout folder we will create new file called training page index.xml. And as always we will refer to some core file to make sure we are using the right syntax. We will go to the catalog module again. We can refer to any file, let's say catalog category view. We don't need the whole file. All we need is just this piece. So we don't need tops, we only need reference to the content. The class would be Magento framework view element template. Name would be training pages, and template would be Magento U training pages. Let's do it just pages HTML. Okay, now we want to add a view model to the block, and that's it. Reference container, body, and page. And we will use the same to columns layout. Here now, to add a view model, we will need arguments. We'll create an argument, name view model, exercise type object, and we will specify a class here, the Magento U training view model pages. Now we should create this file, and we should also create a template after that. So let's go ahead and create a view model, and in the view model we will create file pages.php. So now we can proceed. We can create this file. So we would use a namespace Magento U training view model. We will use Magento framework view element block argument interface. We will create our class pages, which implements argument interface. And then this is totally custom class. There is no method in the argument interface. We only needed to pass it as a view model. We would need a few more classes, so we would use Magento U training model page factory. We will use Magento U training model resource model page collection factory. Now we create a constructor, page factory, and collection factory. Here put this page factory, and this collection factory, also collection factory. We will create protected variable, protected page factory, protected collection factory, and we will write the blocks comments var page factory and var collection factory. We'll write here also comments param page factory also be param collection factory. Okay, now we create a method it would be available in our blog of the function get pages, get all pages, which would simply return our collection, return this collection factory, create, and we'll create public function get page by ID, which would return page. This page factory create. So this is how we create an instance of our model. Then we use page load by ID and return page. So please note that this record will load page from database, and when we for each our collection, it will also load pages from database. So from the performance standpoint, this is not the best idea to do like that. It's better to load everything we need within one operation and then use it. But we just want to demonstrate how we can work with that. So we go into templates and create file pages.html. In this file, we will have some header, all pages, and then we will, for each our pages, so we will have a variable pages, get all pages, then we will have for each pages as page, and we will echo them, echo. So we will have h3 echo page get name, and then we would have, let's make them in the div, and then we would have let's say code, and then we would have price, all fields of our page. And finally, we will use our second method, first page, and we will say page equals this get view model, get page 1. So we'll have code ID here, and that would be echo page get name, say page get code, and page get price. This is our method. We are all set now, so we can run a terminal. We have to clean the cache. Okay, cache is cleaned, and now we should go to the front and check and see the result. So now it's time to check our code. Before we do that, there are a few little fixes that we have to do. So first of all, in our index.php file, in Magento U training controller index.php, we have to fix it. There is no action context, it's action context. And we have to add t here, so it should be context in the constructor. Second thing that we have to fix is misspell view here. And now we can look into our page. So this is how it looks like. So we go to training page index and we can have information on our page. So we have our code, second page, another page, simple page, and test page. To summarize, this is how we work with models and collections. So we may do something more sophisticated here. We could say collection, create, and we could filter it. We could use collection, add field to filter, and we may say something like name, and here we would do like simple. So we can do something like that, return collection, and return collection. Save the file. We might need to clean the cache because it's full page cache here. And now we can take a look at the result. So we filtered it and we have only one page now, simple page. So this is how we work with collection. The same about models, so we can load model, we can save. It's not a good idea to save on frontend, but we could do something like page, set name, another page, and then save. So we could do something like that. I wanted to save our objects. And this is how we work and test our collections and our pages. Please note that this is also not a good idea and not a good practice to add filters directly in the view models or so. So if there is a method that you need to filter, it's better to create it in collection. So it would be get filtered items, get simple collections or so, and you would have this code collection add filter inside. So we would say here get simple pages. This doesn't make sense in this example, but this is a better practice to not use SQL type statements, and this is technically, we add a SQL filter here. There is some SQL, you see some SQL syntax. So it's better to not do that. But if it's only one filter and it's specific to our view model, we don't need a method, we can still do it in our view model as well.
See a course exercise guide for instructions on how to complete this exercise and its solution. See a course exercise guide for instructions on how to complete this exercise and its solution. We now shift to a discussion of entity attribute value concepts in Magento 2. This module covers the EAV database storage approach, which tables are part of the EAV concept, and how these tables are related to each other. This module also describes the PHP classes that make up the EAV implementation and how they interact. In this module we will discuss EAV storage concepts, the table structure, storage concepts, the class hierarchy and the process, the value of using EAV, and how Magento 2 uses EAV. Magento engineers have implemented an object attribute to table column mapping model to accommodate a wide range of requirements for the display and description of products, meeting the needs of each website as well as multiple ranges of storefronts. In practice, this means that the Magento EAV model spreads out the entity and the attribute descriptions over a number of tables. This also provides the flexibility to expand attributes for products and other entities to meet future website expansion. Typically, we store data in plain tables like the one shown. Business entities and their properties, for example products and their SKUs, are reflected in the table structure, where each property has a corresponding column. Some of the common data storage issues that confront developers are multi-scope values. It is cumbersome to represent different values for multiple scopes like global, website, and store view when using a flat table structure. Adding and removing new fields. With a flat table, adding an attribute means altering the table to add a new column. Changing the type of fields. Changing the field type, that is int, text, varchar, and so on, also means altering the table. EAV helps to overcome some of these common data storage issues because it separates the values from the attributes and entities. It encapsulates attribute-related business logic, it makes multi-scope values easier, and it makes adding and removing attributes very easy. One aspect of EAV is managing relationships, that is, the meta-information about the available entities. The meta-information includes the entity type, the attributes per entity type, and attribute sets and groups. This slide shows the table relationships of the four main tables of a classic EAV implementation. First, we have the entity type. This table has one record for each entity type that is available in the system, for example products, categories, and customers. Each entity type is identified by a unique entity type ID and a unique human-readable entity type code. Besides specifying what entities exist, there is no additional information about the entities available so far. To store further information about entities, an attribute table is part of the system. Each record in the attribute table is linked to a specific entity type via the Entity Type ID column. Each attribute is identified by a unique attribute ID and a human-readable attribute code. The attribute code has to be unique within a given entity type. Given the example on the slide, we now know that products have a name, a description, and a price, and customers have a first name. But there still are no actual entities, only the meta-information about entities can be read from the entity type and from the attributes table. To store actual entities, a content table is needed. To create an entity, a record is added to an entity table. A unique entity ID identifies each entity. And every record is linked to a specific entity type record through a foreign key constraint on the entity type ID column. You must agree that there still is too little information stored about each of the entities to be useful, as so far they only consist of a numeric entity ID. To store the actual attribute values, another table is needed, attribute value. Each attribute value is linked to an entity and to the attribute. Now we can determine that the first name attribute value of the customer with the entity ID 3 is John. Even though this storage schema is not completely normalized, it does not contain a lot of duplication. But it has a number of issues. The tables grow very large. Information about different entity types are all mixed together in the tables. MySQL is unable to create an efficient index on the attribute value column, thus making queries by attribute value extremely slow. And for humans, it is hard to read the table. To resolve these issues, Magento engineers introduced some changes to the classic EAV storage model. This slide build walks you through a simplified Magento-specific EAV implementation, pointing out the differences to the classic model. Please note that the real tables contain more columns, but in order to understand the EAV table structure, they are not important. We will discuss those later. It starts again with an entity type table. So far, there are no structural differences. Each entity type has an ID and a code. The EAV attribute table contains some small differences to the classic model. One of those is that each attribute's data type is recorded in a column called backend type. Now the system knows that the name attribute is a varchar value, price is a decimal, and birthday is a datetime value. For storing the actual entities, Magento introduced the first big change. The entity table is now split by entity type. Each entity type has its own entity table. All product entities, for example, are stored in a table called catalog product entity. Customers are stored in a table called customer entity, and so forth. As a consequence, the number of tables grows, but the size of each table is smaller. Also, it is easier for us humans to read the tables because we know now what entity type we are dealing with when we are looking at a table. Another change Magento introduced is that the values of all attributes with the backend type static are stored in a dedicated column in the entity table. For products, for example, the attribute SKU is static, meaning there is a SKU column in the product entity table. For the attribute values, Magento introduced the second big change from the classical EAV structure. The attribute value table is not only split by entity type, but also by backend type. For example, the values of customer attributes with the datetime backend type are stored in the table customer entity datetime. This means the number of tables is even larger, but the number of records in each of the tables is a lot lower, and the performance during conditional queries is a lot better because the database is able to create efficient indexes on the value columns. Note that the columns of the attribute value tables are identical. The only difference is the data type of the value column. The following list highlights some of the differences between Magento EAV storage and classic EAV storage. In Magento, the core EAV tables are prefixed with EAV_. Each attribute is assigned a backend type. Example, varchar, int, decimal, text, or datetime. The entity tables are split. Each EAV entity now has its own entity table. For example, catalog product entity, catalog category entity, and customer entity. Special unique attributes with a global scope are integrated into the entity tables. For example, the customer email address or a product SKU. These special attributes have the backend type static. The attribute value tables are also split by entity type and additionally by backend type. So customer entities are stored in the EAV entity table customer entity, and the associated attribute values are stored in the EAV value tables customer entity ID, customer entity varchar, customer entity decimal, customer entity datetime, etc. For performance reasons, some information is duplicated between tables. Magento has added the capability to organize product attributes into attribute sets to facilitate different types of products. Each attribute has several attribute groups. For example, prices. An attribute that is associated with an attribute set is always linked to an attribute group. A store owner can create new attribute sets and groups as needed. The sole purpose of attribute groups is to create clarity in the backend interface. There is no functional difference between attribute groups. Each EAV entity in Magento has at least one attribute set, called default, although it is not obvious in the admin interface, except for products. As a result, each attribute set has at least one attribute group, general. Above is a depiction of the EAV hierarchy. Entity types form the basis of the Magento EAV model. Each entity type has one or more attributes and attribute sets. Each attribute set has one or more attribute groups. Every attribute is associated to exactly one entity type, and one or more attribute sets via attribute groups. The EAV entity type table contains the different entity types. The EAV attribute table contains the available attributes for all entity types. Some entity types require additional attribute properties. For example, the property used in layered navigation is only useful for product attributes, not for customer attributes. These additional attribute properties are stored in the additional attribute tables, catalog EAV attribute and customer EAV attribute, for example. The additional attribute tables are specified in a column of the EAV entity type table. The EAV attribute set table contains the attribute set declarations. The EAV attribute group contains the attribute groups. The EAV entity attribute table links all the information needed to render the product backend interface: entity types, attribute sets, attribute groups, and attributes. Entity attribute values are stored in several related tables. The default table an attribute value is stored in is determined by the attribute's backend type property. The concrete table name for the attribute values is built by appending the backend type to the name of the entity table. Attributes with the backend type static are stored in the entity table itself. All properties of entity types are stored in the table EAV entity type. It is a good idea to be familiar with the main fields of this table when working with EAV entities. When creating new entities, it is good practice to study all available properties. The main properties of entity types are entity type ID, which is the unique numeric identifier that is used throughout the system in many places. Entity type code, which is the human-readable unique identifier of the entity type. Then there is the entity table, which is just the name of the entity table. The default attribute set ID is the attribute set ID which is used when no attribute set is specified on a new model. And the increment model is the PHP class name that handles increments for this entity type. All common properties of EAV attributes are stored in the table EAV attribute. You should be familiar with the main fields of this table when working with EAV entities. When creating new EAV attributes, all available properties should be known. First, the entity type-specific attribute properties are stored in an additional attribute table, for example, catalog EAV attribute. The main properties of EAV attributes are the attribute code, which is a human-readable identifier of the entity type. It must be unique within the scope of the associated entity type. The backend type is the data type of the attribute. Native Magento uses static, varchar, datetime, int, text, and decimal, and custom types can also be used. The backend model. Attribute backend models are used to process attribute data before or after CRUD operations. Source model. Attribute source models are used to provide the options for select and multi-select input type attributes. Finally, front-end models are used to format attribute values for display. When rendering multi-select and select input fields, the source model supplies the list of possible attribute option IDs and option labels. If a multi-select or select attribute option is rendered, for example, on the product detail page, the front-end model uses the source model to render the correct label for the attribute option. This module on EAV attribute management discusses the practical application of the EAV concepts in Magento 2. In this module, we will discuss creating and customizing attributes. Managing attributes is about customizing attribute properties that define the runtime behavior. Each attribute may have some additional entity type specific properties which would be stored in additional tables, such as catalog EAV attribute. First, the attribute ID, the unique ID from the EAV attribute table. The entity type ID of the associated entity type. The attribute code. The attribute code must be unique within the associated entity type. The attribute model is the optional alternative model to use. It defaults to Magento EAV model entity attribute if not specified. The backend model is the optional alternative backend model. It defaults to Magento EAV model entity attribute backend default backend if not specified. The backend type is the data type for the attribute. Usually it's one of static, varchar, datetime, int, text, or decimal. Custom types are possible too. The backend table, it's an optional value for the table, which defaults to the entity table name with the backend type appended to it, separated by an underscore. The frontend model is the optional alternative frontend model. It defaults to Magento EAV model entity attribute frontend default frontend if not specified. The frontend input is the input type for the attribute if the Adminhtml form is rendered automatically. Frontend label is the default label if the Adminhtml form is rendered automatically. The front-end class is an optional CSS class name which will be added to the Adminhtml input element if the Adminhtml form is rendered automatically. This is useful for JavaScript validation. IsRequired enables JavaScript validation if the Adminhtml form is rendered automatically. It is evaluated during data flow and import-export processes also. And finally, the default value is the optional default value for the attribute. It is displayed by the front-end model if the attribute has no value on an entity. Again, recall that there are two aspects to the EAV process: managing relationships and managing content. Information about the meta aspect of the EAV system can be accessed using the EAV config model Magento EAV model config. It aggregates access to the meta information about entity types and attributes. There are a couple of generic EAV classes that you can use to get information. One of these is Magento EAV model config, which was mentioned on the previous slide. It is a very useful class for getting meta information. Accessing the EAV entity type and attribute models is easy. The method getAttribute on Magento EAV model config returns an attribute instance. It takes the entity type and the attribute code as arguments. The method getEntityType takes the entity type code and returns an entity type instance. The Magento EAV system offers the listed backend type variations by default. Custom types can be used as needed too. There is also the static attribute backend type, which indicates that the attribute values are stored in the entity table. The EAV setup class, Magento EAV setup, must be used to work with the attributes and entity types in module setup scripts. For this reason, it is a very important class. The EAV setup class implements methods for manipulating entity types and attributes. It is used by the install data or upgrade data setup classes of modules to add or modify EAV entities or attributes. Two examples of the methods that the setup class implements are addAttribute and updateAttribute. Note, the updateAttribute method property argument exactly matches the column name in the database, while for addAttribute, the property names of the data array are filtered through Magento EAV model entity setup property mapper interface map by the setup class. For example, addAttribute uses label instead of frontend underscore label. This mapping is defined in the mapper implementation Magento EAV model entity setup property mapper. A list of addAttribute property names. To accommodate additional attribute table column mappings, a composite property mapper is used, Magento EAV model entity setup property mapper composite, which is configured using the IXML. For example, in the Mage catalog the IXML, here is a code sample of adding an attribute to a product. Note, properties do not have to be specified in the input array if their default values are sufficient. A reminder of the functions of attribute backend, source, and frontend models. Backend models provide hooks before and after save, load, and delete operations with an attribute value. Source models provide option values and labels for select and multi-select attributes. Front-end models prepare an attribute value for rendering on the front end. Backend models can be an alternative to an observer or a plugin, for example, when you have to do something that depends on an attribute value when an entity is saved. Magento comes with a number of backend models that can be used for custom attributes as well. The models can be found in the directory app code Magento EAV model entity attribute backend. Magento comes with a number of attribute source models that can be used for custom attributes too. The models can be found in the directory app code Magento EAV model entity attribute source. The number of front-end models Magento provides out of the box is very limited. These models can be found in the directory app code Magento EAV model entity attribute frontend. See your course exercise guide for instructions on how to complete this exercise and its solution.
Congratulations, you have completed Unit 4. Close this window to return to the Learning Management System and proceed.